Been doing a lot of thinking. Good morning, YouTube. Here with you at 9:03 on a Wednesday. Been away from the YouTube for a while, as you can probably tell. Back again. I won't say I'm back 100%. Obviously, I'm not, because I'm doing this kind of video. But anyway, I thought I would take a look at an idea. You know, one of the things that I do, or I can do, while I'm mending from this gout problem, is think. I have a lot of time for thought, and I've been thinking about a new project, and this may have been done before. I don't know. It may not. I don't know. But what I've got in mind is a radio project that. Well, let me just get into it, and we'll show you what I'm talking about. Alright, here's your diagram of a typical super heterodyne receiver of the AM variety. It's pretty simple in its basic thing, but there's one thing missing, and I don't know how many people realize this, but you know, all these diagrams, you know, I put in this diagram in Google, or this search term in Google, and this is what I came up with. The predominant thing I came up with was these particular stages, sections, whatever you want to call them. But there's one thing missing, and I'm going to point that out right now. Yeah, you got to have a power supply section, or else none of this is going to work. I mean, it might work a little bit with an earphone or something, but there's not going to be any speaker output without a power supply. So, you know, I think that's a necessary and obvious omission from these diagrams that nobody seems to want to put in there. But anyway, that's my idea on that. And so let's take a look quickly at the various sections. We'll begin with the RF here. Let me get that up. Alright, now we can see the RF section is on the screen, and basically what this involves, or what this does involve, I should say, is a means to receive a signal. That's the antenna right here. This is what is put up in the air, or whatever you want to call it, to get the waves, the RF waves coming in, and pick those up and bring them into this coil here, and also this capacitor here, which is hard to see, but it's tied to this capacitor down here on the local oscillator, and together they form the RF section. Now, in its simplest form, one active device will do all the functions of it. It will amplify the signal, and it will also mix the signal with the local oscillator signal. So that's pretty much the RF section. And let's take a look at the next one. Now, the IF section is also pretty simple. It just basically takes input from the RF section and basically filters it. And that's exactly what a IF does. And IF stands for intermediate frequency, if you didn't know. But it basically filters out all the unwanted signals. And just for an example, 455 kilohertz is what we're going to use for our filter frequency. And basically anything besides 455, it takes and gets rid of. Now, after it filters it, comes out here. This is a filter output, and it goes into a detector stage. The detector stage, what it does is separates the audio from the RF, and can send that way the audio to the next stage. There it is in its simplest form. The audio amp is basically just that. It takes the output from the detector which is a very low level audio signal, and amplifies that and puts it out the speaker. That's pretty much all a radio is those stages. And again, you have to have a power supply for all that, but we're not going to talk about that too much today. Alright, first thing let's look at is the RF station or section here, and this happens to be a tube section or tube-based RF section. Again, same thing. The antenna over here brings in the signal, and it is filtered somewhat with these capacitor and filter from the antenna or antenna coil, whatever you want to call it, and it goes into the tube here. And also at the same time, this tube is oscillating, and it uses this circuit right here to make the oscillator frequency, and that is combined with the incoming RF. And as you can see here, there is tied the same way as the other one. There's two ties here, or one tie here, from this capacitor here to this capacitor here. So that keeps it on frequency. In other words, it matches the frequency coming into the frequency of the oscillator to keep our 455 kilohertz as a primary output, and that's what it's designed to do, and that's what it does. And the output from that, in this case these two here, go to the IF section, and that's what we're going to look at next. Now on this one we have a solid state transistor based IF section, and it works the same way as a tube base would, and basically it takes the output from the RF section here and filters it again. This particular IF section has three transformers for filtering, and has two active components with these transistors right here. Basically it filters, the first one filters it down, amplifies it again. Second transformer filters it again, takes it to the second amplifier, and that amplifies again, and then it takes it to the detector. From the detector it goes to the audio section. Now on the audio section, you see I've once again changed our basing. This one's IC based. Basically the signal from the IF, the audio, low-level audio signal, comes in here and is amplified by the LM386 and is outputted here at the speaker. Now that's a very simple design, and that's all that's really necessary for this to work. And you may be asking, why are you going over all this stuff? I mean, everybody knows this. I understand that. But what my new project involves is just this. I want to take and make a radio from three different basic basing, in other words, tube, transistor, IC. And I'd like to build a radio from that. It doesn't have to be this particular order. In other words, it could be an IC based RF section. I don't care. It doesn't really matter. It can be split in any way you want to, but I want basically to build a radio that will take a signal, and you know, that's all this is. All we are dealing with here is a signal. Doesn't matter how it's obtained, rather tubes or transistor or IC. It doesn't matter how it is gained or whatever you want to call it. Basically, what this experiment's going to be is involved in coupling the various stages together from one to the other, and that's the interesting part to me, I think. This has a lot to do with my substitution type troubleshooting that I was doing here for a while, where you can take one signal from one radio and use it with another radio, and that's basically what we're doing here, is you know, taking one signal from one type of circuit to another type of circuit and having it perform the same function. And that's all that really it matters on stuff like this. And the interesting, I won't say the interesting, but the complicated, probably most complicated probably section of this is the power supply. And for our purposes, it's going to have to supply a tube, which is usually a high voltage type supply, and it's going to also supply transistors, which is we'll call medium based or medium level power supply, and then the IC is going to be a low level power supply. So you can see the 5 to 12 volts here is all that's necessary for that IC to function. And so that's what I'm trying to look at. And what I want to do is basically put this out there and see if anybody wants to join me in this. I kind of like to make a collaboration type video for this. Have one person do the RF section, one person do the IF detector section, and one person do the audio section, and then the most important one is the power supply to connect them all together and make it work. Anybody that wants to join me in this, I would appreciate it. Leave your comments below if you're interested in doing this, because I think it would be kind of a neat little project to do, and something fun at the same time. You know, it's kind of a proof of concept, but at the same time, it's just you know, a hybrid radio like this would be, you know, something to have. Franken radio, whatever you want to call it. But you know, it's just like I said, it's just interesting to see how well the different devices and electronics can function together, and you know, for the common good, as it were. So that's my idea, and that's my goal on this is basically to get a little project going. Like I said, everybody, anybody wants to do this. There's going to be 4 people basically, one for the RF, one for the IF, one for the audio, and one for the power supply. So that's what I'm going to be needing. Now, anybody else that wants to help is you know, welcome to. There will be some logistics involved, as well as stuff like that. So you know, that's what I'm kind of looking to do. And if you're interested in this, let me know in the comments, or send me an email. As you know, all know my email address, or you should. I'll put it down in the comment in the description, just in case. But like I said, let me know. It'd be kind of a fun thing to do, I think. And if you don't agree, let me know that too. I mean, that's fine. I just you know, like I said, you're on the mend from ailing from something or other, and you do a lot of thinking, and that's basically what I've been doing. This is, like I said, also combined with that signal substitution that I did troubleshooting series for a while, and it's all along the same lines, because you know, my estimation, you can you know, you should be able to use any RF signal to any IF signal, as far as whether it's tube based or solid state or whatever, and it should work the same way, I think. And so, like I said, that's kind of an interesting thing, I think, would be to look at. So again, if you think you would be interested in helping me with this, and maybe doing a part of this, let me know, and we can go along from there and get together via email or whatever, and check it out. So, alright, that's going to do me, you guys. Like I said, this is the only kind of video I really felt like doing today. My hand is better. It is, I'm going to say, somewhat useful. I can type a little bit. I can, you know, basically hit the shift key with one hand, my left hand, and then type with the other hand. So that's better than it was, we'll put it that way. There was a time that I couldn't even hit the shift key. So like I said, I've been getting fairly good rest at night, and I've reduced my Tylenol to basically once a day now. I take it right before I go to bed, and that helps me to sleep and get a good night's sleep, and that way I you know, I wake up with a somewhat better attitude in the mornings usually than I do at night. So anyway, that's what I've been looking at and what I've been doing, and I am still alive, as Bill said. And so you guys, I thought I would just go ahead and put this out there and see what you think, and let me know, and we'll talk to you later. Thanks for watching. See ya!